Okay, calculus. We are going to be looking at number 34 here. Volume. This is the 3D rotation that we've been talking about, hinting at, coming up here in class. But we have two kind of buzzwords, a disk and washer. And just keep in mind what's the difference between a disk and a washer. Well, a disk is completely filled, it's full, while a washer has some emptiness in it, and that's having to do with some negative space, and we'll be coming back to this idea of negative space and how to calculate that, but essentially it's the whole thing minus the inside gives you the donut or the washer. That's why they really call it the disk and washer method. No other real reason. But let's see how this plays out. First, we start with the disk method. So there's a whole bunch of stuff going on here. But the general idea is if you take your vertical measurement, which I'm coloring in here in blue, we're going to call this is our radius. And I'm going to make sure that it's capital R here because it's a long radius. And if we take that and we rotate it around 360 degrees, we can turn it into a circle because we know that a circle, the area of a circle, is pi times the radius squared. So essentially what we're going to do is add up a bunch of these circles all the way down, and then we get this 3D rotation that fills it all in here. And that's what this volume is really doing. Now I know that this is kind of like the width of a disk along the x-axis and along the y-axis, and we'll kind of break down what's the difference between those and how that works. But it's really saying, are we going horizontal or are we going vertical? Because when we go vertical, our rotation now is going this way. Okay, so we're going to look at some visualization tools as well to see this in class. But for the most part here, I'm going to be looking at the algebra and the setup for the calculus. Again, this is a very big calculator type problem. I'm going to get my calculator warmed up there. You guys should get yours out as well. Now, on the other side of this is the washer. Notice in here that we have some inside hole. We got like this inside hole. Oh, there's our calculator popping up on the screen. Here, this purple piece. And the idea is that we're trying to find, let's say it's maroon, this kind of disk around the outside. And in order to do that, we got to take the whole thing. So if we were to start with the whole disk, and then we were to subtract the purple there, minus the purple, you would get this donut shape. And that's really how we're kind of getting those pieces. So how do we do that? Well, let's color this outside here before I get ahead of myself. This first one in blue that we're talking about, this is a volume integral that we were saying before. We got the integral, we got a pi in here, and we got our r squared. We're going from a to b, of course. That goes with finding a definite area. Then this purple one is like a little r. We're going to call this a little r. See right there, it's lowercase r. So that's going to be the integral again from a to b and pi, and then we got a little r squared. Then we're going to subtract. Now the cool thing about this is that we can combine things a little bit and we can actually simplify. In fact, it's almost like factoring. They both have pi in common, so we'll pull that out. And then we have the a and b in common, so we'll still go from a to b for both of them. And then it's just the difference, big R squared minus little r squared. We'll call it like R1 minus R2. Do remember that these need to be squared. It is not big R1 minus little r2 quantity squared. It is not that. And in fact, that's a very common error that you guys will see as we go through this. And if you were to do this, you lose a good amount of points, especially on like a free response question. So let's take a look. Let's just jump right in. Okay, here's kind of a process that we're going to be going through. We really have to watch which way we're rotating around, whether it's going to be a dx or a dy, but I'm going to highlight that kind of as we go. And if it's a disk problem, we just need the capital, and if it's a washer problem, then we need both the big radius and the little radius. That's a lot of details. So let's just kind of look at one of these and see how that plays out. Find the volume of the region enclosed by y equals 2x, y equals 0, and x equals 3. And it's rotated around the x-axis. Okay, so let's play this out. Let's go ahead and draw our picture here. So we're going to have three functions. We're going to clear all this. Let's see a large screen for you. So for my first function, it was 2x, I believe, y equals 2x. Then we got y equals 0, and x equals 3. So if we're to graph that, and we got this picture, let's go ahead and change our zoom to a standard here. So zoom standard, just to have a fairly simple picture. Now we're going for this distance from 0 to 3. We're going to cut it off right at 3 there. So how do we calculate that area? Well, let's go ahead and draw it. I'm going to drag mine onto the screen, and then we're going to see how we're going to take this area. All right, so there's mine. Now I know that my radius is really the distance between these two lines, and this is why we had to learn how to calculate the area between two lines. So let's go ahead and surround this in blue. So we're taking this area and then we're going to rotate it three-dimensionally. So we're going to rotate it three-dimensionally. That means I'm going to have something that looks kind of like that. I'm going to take that thing that I just drew, fade it out a little bit so you guys can kind of see what's happening. So we still have this blue area, and it's going to rotate into these little circles. So to find the area of one of those circles, I got to figure out what is my large R and what is my little r. So the first radius is this distance, and again, that large R is going to be just like the area between two curves. So we need a top minus a bottom. And in this case, our top is this line. So the top is really 2x, and then the bottom is this line here, which is y equals 0. So that's my big R. So it's 2x minus 0, or just 2x. Now when I'm rotating around the x-axis, here's where it gets really interesting. What I'm looking at is this zone here. Am I attached to the axis? That's my question. Am I attached, or is there a hole on the inside? And it's attached. So that little r right there is actually nothing. It's 0. So it doesn't even get counted. So now how do I set up the volume? Well, remember that the volume is the integral from a to b of big R squared. Then we got a pi times our answer there because it's pi times r squared, the area of a bunch of circles. Now since we're moving left to right here for this question, that means we're going to have dx. Okay, so fill in the pieces. That would be pi. Now where do we start? Looks like we start here and finish here because we got a vertical line here at x equals 3. So we're going to start at 0, end at 3, and we're doing big R squared, which in this case is just 2x squared. And we got a dx. Now from this point, this is a calculator problem. I wouldn't really take it any further than that. I would figure out what this piece is here using my calculator and then multiply it by pi, and that would be my answer. This is very much a calculator type situation, but honestly, setting it up, we're good. Let's keep practicing this whole setup. Okay, the line y equals 6 is going to be our next rotation. So I'm going to take the same picture, copy and paste it. So when I'm rotating around the line y equals 6, this changes everything. So let's go ahead and give ourselves a horizontal line here at y equals 6. So I got 1, 2, 3, 4, 5, 6. So we're rotating around that line. Now, the reason that's really different is because the original blue area that we had outlined, which is going from 0 to 3, 1, 2, 3, so there's our blue area. Now, instead of rotating around like this circle that we just had, it's actually going to be rotating the other way. So I'm going to take and make an ellipse here. We're going to make the inside empty, and we'll keep this blue. So really that means that we're rotating kind of around like this. I'm going to take that and fade it out a little bit for you guys. There we go. Okay, so that's our rotation. So now this is very weird. You know, the reason it's weird is because a lot of stuff changes. Our big R is now completely different. This middle line, this axis, is kind of what you would think of as our top. And this bottom line here would be kind of the bottom, but then we're going to see something else. So what is this big R? Now that creates a cylinder. See, it's the same here, it's the same here the whole time. So this big R is just 6. It's 6 units long. Here's where it gets really interesting. Notice that here's our axis of rotation. And we have all this empty space. And with all that empty space getting rotated around, we're cutting out a hole. So we're not attached because there's a hole here. Now because there's a hole, that means we got to figure out what the little r is, which is this distance between these lines here. So that little r again is going to be the top minus the bottom. And what's the top line? Well, that top line, what's this line on top here? This is a 6. And what's this bottom line? That's our 2x, y equals 2x. So there's our little r. So we got 6 minus 2x for the little radius. And for the top radius, that's just 6 in itself. Okay, so how are we going to find this volume? Well, we got to remember that it's going to be A to B. We got a pi out here. We're going to have our big R. Let's call it R1. We'll call this R1 and R2. Squared minus the integral again from A to B of pi times little r2 squared, the inside radius. Okay, so how are we going to calculate this? So what we would type into our calculator is the integral from A to B. So what's our A to B? Looks like we start here at 0, go to 3. That should still be the same for us, that blue region there. So we're going to go from 0 to 3. We're going to have a pi out here. But now it's going to be the big radius squared minus the little radius squared. And the big radius squared is just 6. The little radius squared, it looks like I need a little more space for that. It's going to be 6 minus 2x. And again, how do we figure out those distances? It's always the top minus the bottom. Now the first one, it was just 2 horizontal lines. It was really 6 minus 0 if you want to get picky. So that's why it's just 6 squared. Of course, we got our dx. And again, we're just going for setup here. If you can set it up, you are golden. So this next one, what is the difference here? Notice that this first one's a horizontal line at 6. The second one is a horizontal line at 8. So again, I'm going to copy and paste this here. Excellent. And now we're going to do a horizontal line at 8. So I'm going to draw a horizontal line, but at 8. So we're going 1, 2, 3, 4, 5, 6, 7, 8. There we go. Now I want that line to be not blue. We want it to be probably black. Okay, so there's our horizontal line. Let's trace our region that we were finding the area of. Again, it was from 0 to 3 and between these lines. So here's our region. And if I'm going to rotate it around this y equals 8, so take a look at what's happening here. So we got y equals 8, this blue area, we are not attached, so there's a hole in the middle. That tells me that I'm doing like that washer method where I got to subtract the little r. Let's figure out what our big R is and what our little r is. Okay, so our big R, let's kind of summarize this a little bit. The big R, to really figure that out, we're looking at big R is going to be the top minus the bottom, but it's usually, you know, the axis. It's kind of like I can't even think right now. It's the difference between the rotation axis, the axis of rotation, and the outside edge. So what's my outside edge here? My outside edge, there's my outside edge, outer edge. And up here, this black line at y equals 8, that's my axis of rotation. So I'm going to have 8 minus the outside edge is really just y equals 0. So that's my big R. And what's my little r then? What are these lines here? How do I create those lines? Well, that's going to be the difference between, so again, let's do this as R1. Our little r2 is going to be the axis of rotation minus the inside edge. And the inside edge is this part here on the hole. And what is that? That's actually a line. That's a function that we have there. So again, now we're going to have 8 minus that inside edge is 2x. So let's fill this in here. We got 8 minus 2x for little r. For big R, we're going to have 8 minus 0. So what's the overall integral? If we're to work this out here, we're going to be doing the integral again from the same, limits here, going from 0 to 3. So from 0 to 3, we're going to multiply by pi, and then we have in here our big R squared minus our little r squared, and our little r is actually a little more space to write, dx. So we would have 8 squared minus 8 minus 2x quantity squared. There's our setup, and the setup is all that we're really looking for. Okay, so let's take a look at this next one now. Same functions, but now we got crazier stuff. Okay, so now we're going to rotate around the y-axis and x value. So something completely changes for D, E, and F here. Now we're talking horizontal versus vertical. Because I'm going to take that same thing, I'm going to copy and paste it. So here, let's take this same picture. The original picture did not change. So there's our original picture. But now we're going to be rotating around a line, in this case the y-axis. Let's start picking a color for y-axis. How about purple? So I'm going to make a line, but this time it's vertical and it's purple. So there's my axis of rotation. Now if I were to give this what you would say like a function, the y-axis is really x equals 0. Alright, now let's look at these other things here. So here's the region that we were going for, x equals 3 from 0 to 3. So here's our region. But now the major difference is we're going to rotate around horizontally. So we're spinning around this way. Now I'm going to draw some circles in here so you guys can see what that really means. That means that are discs or washers, however you want to call them, would look like. So let's draw a washer in here, or disc. Oh, we don't want it filled in. We want that empty. There we go. So here's 3. There we go. So that would be a washer right there. Okay, so that's the piece that's spinning around. Now, remember that our big R, we'll call that in blue, is going to be the axis of rotation minus the outside edge, or the outer edge. Now, if we're trying to do the axis of rotation minus the outer edge, something drastically changes with this. Now we're measuring a horizontal distance here, not a vertical distance, which means that all of our things, all of our equations here, need to be in terms of x. Now this first one, that one's fine. So that's good, check, x equals 3. Y equals 0. Now that's kind of an interesting thing. That's the x-axis. But this y equals 2x, we got to change that. So if we were to solve this for x, that would be x equals y over 2. So that's this line here. This is x equals y over 2. We're going to be using that in a second. In fact, let's color that red because we're probably going to use it for the inside radius. So let's start with this outside edge. If we're going from here, the axis of rotation, to here, the outside edge, at x equals 3, that's the radius of that cylinder that's being created. So that's going to be 0 minus 3, or 3 minus 0. And in fact, it doesn't matter if it's 3 minus 0 or 0 minus 3. Can anybody guess why? Because when you do the calculation, it's going to be r squared. And when you square it, the negative and positive are the same thing. So I like to say just the axis of rotation minus the outer edge. And that's just easy, simple, straightforward, consistent. So now we got this hole on the inside, because see, if this is my axis of rotation, I'm not attached. I have a hole, which means I got to subtract the inside pieces, which are all these lines. Okay, so how do I find little r then? Again, that's the axis of rotation minus the inside edge. Okay, so here we're spinning around and we got this axis of rotation, which is really 0. And that inside edge is now a function. It's this slanted line here, which in this case is in terms of x. So it's going to be y over 2. That's where I had to use this. So what is my overall setup then? That means I'm going to be doing different integrals here, because now my limits are in terms of y. So y equals 0, and where do I finish? I finish up here at y equals 6. So I'm doing the integral from 0 to 6 pi, and then it's going to be big R squared minus little r squared. Now because there's zeros in there, I can just say this one's a 3 or a negative 3, doesn't matter. And I can say this one is y over 2 or negative y over 2. I'll just say y over 2. Now here's the trick. Doesn't really matter at this point because you would use x's in your calculator to calculate that, but this should say dy. Done dizzle. Okay, so let's look at the second or the next part of this example here. We're looking to go around the line, x equals 3. Find the volume if the region enclosing, blah, 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 blah. Let's copy and paste it again. Hopefully at this point you guys are getting pretty good at redrawing the same graph over and over and over again. So I'm going to enclose this region in blue, just like we've been doing. So we're going from here to here at 3, 6. So there's our little triangle that we're spinning. But now what are we spinning it around? We're spinning it around the line x equals 3. So my axis of rotation is going to be a vertical line. Make it purple right here. There's my axis of rotation. Now, something that makes this a little bit easier for me, just as a side note, notice that I am constantly attached here. So I don't have a big R and a little r. That means my little r is out. Don't need it. I will be spinning around horizontally, so everything does need to be in terms of y. And I just need to figure out what is big R. Well, again, big R, we'll call it big R1, is the axis minus the outer edge. What's the axis? Well, the axis is x equals 3. And the outer edge is this line here, because it's lines here that go from this edge to this axis. Kind of losing some of the definition there. So this outer edge to this axis, and we got these lines going across. And the outer edge is x equals y over 2. So R1, you could say, big R, is 3 minus y over 2. What's the volume? Well, the volume, again, we're going in the y direction, which means our limits have to be in terms of y. We start down here at 0. We finish up here at 6. So we're moving from 0 to 6. Ready? And now we're going to do x equals y over 2. Or what's big R? Oh, big R. So we need 3 minus y over 2. Quantity squared dy. I'm forgetting something. Does anybody know what it is? The constant pi out front. Okay, one more, and then we're actually going to pause this video. We're going to make this into multiple parts, just one example at a time, because it takes a while. We're like just into this, and we still have a lot of examples to go. Okay, so we got the same picture, slightly different rotation. Pull it over here. There we go. So now what are we going to rotate around? Well, we start with this blue area. It's good to kind of start consistently here. We're same area. That hasn't changed. We go up to 6, out to 3. And so we're looking for this enclosed region. But now we're rotating around something quite different. We're going to be rotating around not an attached axis, but actually all the way out here to 4. Which gives us a bunch of empty space in the middle. So notice this here. We have this empty space. So we got to do the big R, which is going to go from the axis of rotation all the way to the outside, minus the little r, which is just the inside edge. So my big R is going to be 4 minus, now again we're spinning around horizontally, we're traveling in the y direction, you could say. So this is 4 minus y over 2. Whereas little r, this little inside r, is going to be 4 minus, well, what's this inside edge? What is that vertical line? Well, vertical line is pretty easy. That vertical line is at x equals 3. So it's going to be 4 minus 3. So the little r is just 4 minus 3. The big R is 4 minus y over 2. We'll call this R1 and R2, just like we've been doing with the other ones. So the volume, again, now we got to set this up. We're going in the y direction, so it's at y equals 0 to y equals 6. So we're going from 0 to 6. This is dy. And we got a pi. And then for the big R, it's going to be that one minus the little r. So the big R is 4 minus y over 2. And we've got to square that. You have to square that. And the little one, we could simplify that. 4 minus 3, that's just 1 squared. And here, even though you really should be squaring it, 1 squared is 1. So if you didn't have it there, you'd still be correct. Okay, that was a lot just for one example, even though it had 6 parts. We're going to do each of these kind of separate here. Hopefully you guys can watch them a few at a time. But that's it for this part. I'm going to do example 2 in the next video.